Alrighty, statisticians, there was a couple of things that I wanted to review after the last quiz. The first is this sigma notation means to sum up. It means to add all of the individual parts up. Some people still haven't got that down, what that means. If you see just a capital X, it's the variable usually used to represent each individual data value. So the way this works is the sigma, if you see the sigma and the X, it means you add up all the data items. And then you've got N, which is the number of data values that you have. Most people understand that one. Capital N is used if you have a population. Now the X with the bar on top of it, it's pronounced X bar, denotes the mean of the set of sample values. And the mean is if you add up all the data items and divide by the number that you have, number of data items. So add up all the numbers and divide by the number of numbers. I want to make sure that you understand that notation. It'll make things a lot easier. The mu is just like the mean, and I think we don't use it very often, but that's what it is also, a way to denote the mean. Okay, standard deviation. The standard deviation has some important properties that I wanted to go back through with you guys. The standard deviation is the measure of the variation of all the values from the mean. It's how far the data values fall from the mean. It always starts with the mean. It's denoted with an S, and it's usually positive. The value of the standard deviation can increase dramatically if you have outliers. And also the units of the standard deviation are the same as the units of the original data values. Properties of standard deviation. It measures variation among data values. If the values are close together, you have a small standard deviation. If the values are spread apart, you have a larger standard deviation. So that's what that number indicates. It has the same, that was already on the other one. Here's the empirical rule, which we kind of went over. It's in a bar graph in your chart, but if you look here, this X bar down here, that's the mean. 68% of your data falls within one standard deviation. And so they're showing you this is the mean plus a standard deviation. This is a mean minus a standard deviation. Then within two standard deviations, so you go over two standard deviations, the mean minus two standard deviations and the mean plus two standard deviations, 95% of your data should fall between there. And then 99.7 is within three standard deviations. And notice the notation. That's the mean minus 3 times your standard deviation, and the mean plus 3 times your standard deviation. This is the range of values here. And so that's the empirical rule, has to do with normal distributions. Chebyshev's theorem. On the quiz, people were a little unsure about this. So what it states is that the proportion of any set of data lying within k standard deviations, k is the number of standard deviations, is always at least 1 minus 1 over k squared. K is any positive number that's bigger than 1. So let's see how this works. For k equals 2, at least 3/4 or 75% of all the data values lie within 2 standard deviations. Notice k is 2. That's the number of standard deviations from the mean. For k equal 3, you'd have 1 over 1 minus 3 squared, or 1 minus 1/9, which is 8/9 of all the data would lie within 3 standard deviations of the mean. So to find a range of values using Chebyshev's theorem, and this isn't in any of your books, but I came up with, you could think of it as taking the mean plus or minus k times your standard deviation. Remember, k is the number of standard deviations, and the standard deviation, that's a measurement that measures how far apart your data values are. So I would write it like this. There's the mean plus or minus k times the standard deviation. You'd add ks to the mean and you'd subtract ks from the mean. That gives you two numbers, the lower end of your range and the upper end of your range. When given a percentage, find k using Chebyshev's and then use the above to find the range. In other words, you find the percentage. When you're given a percentage, you have to work backwards to find k. K is the number of standard deviations. Then you can put it into this formula that I gave you here to find the range of values. When you're given the range, you use one of the values to find of the range to find k, and then use 1 minus 1 over k squared to find the percentage. That's the difference of how to do these different problems. Let's do a couple examples. So here's one example. Using this theorem, solve a problem for a distribution with a mean of 80 and standard deviation of 10. Notice I made that one blue and this one green, so you can see how it goes in the formula. At least what percentage of values? When you see that percentage of values, you know you're going to be using 1 minus 1 over k squared. Will fall between 60 and 100. Well, first we have to find what k is before we can plug it into that 1 minus 1 over k squared. So what I'm going to do first is I set up kind of an equation. 60 is going to be the mean minus k times your standard deviation in order to find k. The mean they gave us was 80, so that'll go here. Standard deviation is 10, so that'll go in place of your s. So you end up with 60 equals 80 minus k times 10. You would subtract the 80 from both sides, so you get negative 20 equals negative k times 10, then divide by negative 10, so you'd get 2 equals k. Remember, this is the number of standard deviations, not the standard deviation itself. So to find the percentage, all you need is Chebyshev's, which is 1 minus 1 over k squared. So you're going to take 1 minus 1 over 2 squared. That 2 squared is 4, so you'd have 1 minus a fourth, which is 3/4. That's 0.75 or 75%. So that's how you do it going from that direction. They gave you the range, so we found k first and then plugged it into Chebyshev's to find the percentage of the values. All right, so let's go the other way. So it says the mean of $2.60, standard deviation of 15. Using Chebyshev's theorem, find the range in which at least 88.89% of the data will lie. Well, if you notice, you have a percentage here. So in order to use this x plus k times s, we got to find k, and we are given the percentage. So Chebyshev's has already been applied. So we're going to use Chebyshev's 1 minus 1 over k squared and set that equal to our percentage of values. So you'd end up with 0.8889 equals 1 minus 1 over k squared. So if we subtract 1 from both sides, this is 0.8889 minus 1, we're going to get a negative over here. Negative 0.11111 equals negative 1 over k squared. Now when you have these, a fraction where k squared's on the bottom, you can just flip both of them. So in other words, I can just take and say 1 over 0.11111 equals k squared. If you want to do it the long way, you'd multiply both sides by k squared, and then you'd have to divide by 0.11111, and you'd end up at the same point that I am right here. If you do that out, you get 9. 9 equals k squared, and so k is 3. That gives you the number of standard deviations. Now that you know what k is, you can use this relationship, the mean plus or minus k times your standard deviation, to find the range of values that fall in that percentage from the mean. So I'm going to take and I'm going to put 260 plus 3 plus 0.15. Standard deviation was 0.15. 3 is my k, and 260 was my mean. I'd add, or to find the lower one, I'm going to subtract 260 plus or minus 0.45. So I take 260 minus 45 and get 215. 260 plus 45, that's where the plus or minus comes in, gives you 305. So $2.15 to $3.05, that's the range of values. Notice this plus or minus, I split it into two different expressions to give me the lower end of the range and the upper end of the range. So my final answer is 215 to 305. That would be my final range of values. I just wanted to go over this with you because people seem to have trouble with it on the test, and you're going to have an activity in class where you have to go through and practice this, because after the quiz I felt like you guys needed more practice. Alrighty, see you tomorrow. Bye.